So we've covered the basic skills and introduction to the idea behind sequences and series, how we can use these to calculate long-term effects of something fairly straightforward, and how we can work out recurrence relations of simple related quantities. What we're going to do in this one is I'm going to give you a couple of nice introductory questions on this. I want you to pause the video, have a crack at them, come back and then check your answers with the working in this video. So here you go. First one, find the first four terms, u1, u2, u3 and u4, when un equals un minus 1 plus 3, and I tell you u0, the very first term, is 5. Second one, at the end of 1976, the population of India is 611 million, population increased by 2% per year. I want you to first set up a recurrence relation to show Pn, the population growing, and secondly, what is the population at the end of 1980? Third one, in a marathon line dancing competition, 9% of the couples drop out every hour. 250 of them enter to begin with. Start by setting up a recurrence relation showing Cn, the number of competitors left. That's your first challenge. Second one, how long until less than half the competitors are left. So, pause the video, have a crack at these, come back and check. So the first one, find the first four terms when un equals un minus 1 plus 3, u0 equals 5. Now with one like this, it's fairly straightforward. We just have to remember this term depends on the previous term, and then we have to add 3. So we know then that u1 equals u0 plus 3. u0 is 5, so it's 5 plus 3, which I hope you could do by now and get 8. The second term, u2, is given by the previous term u1 plus 3, and again we just take the value we've just calculated for u1 and use that. So it gets 8 plus 3, which is 11. u3 is given by the previous term u2, add a 3, again we've got 11 here for the previous term, so it's 11 plus 3, which is 14, and then u4 is given by u3, the previous term, plus 3. We know u3 is 14, so it's 14 plus 3, it's 17. When it's a nice straightforward pattern like that, it's actually fairly quick and easy to do. You'll notice patterns going up as well, so it's add 3 every single time, so you should be able to identify it pretty quick. Second one, at the end of 1976, population of India is 611 million, increased by 2% per year. Set up a recurrence relation to show Pn, the population growing, and what's the population at the end of 1980. So the first one, we need to figure out how much it's increased by. Well, we know it's increased by 2% per year. So we know it's the equivalent of 102% at the end of every year. But what we want to be able to do is multiply to get that in one quick swoop. Well, we know 102% as a decimal is 1.02. So we know that the next year is 1.02 times the previous year. So we can set up a recurrence relation of P of n plus 1, so the next year, equals 1.02 times Pn, the previous year. That there's the recurrence relation that will give us the answers we want and the numbers we want for the population of India at the end of each year. What we then have to do is it wants to calculate 1980. Now, we're not going to jump in one go. What we have to do is work up to it. So we start by calculating the next year, which is 77. We then calculate the next year, which is 78. Then 79. And then we get to the one we want. We get to 1980. So it's going to be a case of doing 1.02 times the previous year. So to get 1977, we're going to do 1.2 times 1976. We know that 1976 is at 611 million. So for 77, you do 1.02 times that. What you end up getting is 623,220,000 folk. So the end of 77, that's how many are left. To get 78, we just do 1.02 to get the next one. So we do 1.02 times 77 to get 78. When we do that, you get 635,684,400, so it's increasing quite a bit. Then we get the next one to get to 79. Again, we just do the same thing. Multiply the previous year by 1.02. So 79, we get 648,398,088 people. Now that's 1979. We want the end of 1980, so we've got one more calculation to do. We times it by 1.02. Multiplying that by 1.02, you get 661,366,049.76 people. Now, we know we can't have 0.76 of a person. You kind of get 3/4 of a person in a hospital. So what we do is we have to round this up. So we then get 661,366,049 goes up to 50. So that's the population of India at the end of 1980, a hefty number of folk. But it's the same each time. We're just taking the previous year, multiplying it by 1.02 to get the next year. And it's just working it down stage by stage. Last one, marathon line dancing competition 1. 9% drop out, 250 enter, recurrence relation for CN, and then how long until less than half are left. Well, the first one, we have to think of it similarly to the previous. We know 9% drop out, so it's 9% less. So we've got 91% at the end of each year, or at the end of each hour, sorry. So to get that, as a decimal, it's 0.91. So what we're then able to say is that the next hour, Cn plus 1, is equal to 0.91 times the previous hour. So 0.91 Cn. And then we could use that to calculate how many hours it takes to get less than half. Now we know 250, we then know that a half equals 125. Now we want less than that, so even if we ended up with 126, we'd still have to go one more hour because we want less than half the competitors. So we can start by just working our way through. So after 1 hour, we've got 227 couples left. So it's not quite what we want. To get to the second hour, we just take the previous one and multiply it by 0.91. Doing that gets us 207 couples left. Again, not what we want. Same next step. Multiply it by 0.91, you end up getting 188. Starting to get closer to where we want to be, but we're still not quite there. We go again. Times it by 0.91. What you end up getting after 4 hours is 171 folk left. So still not quite there. To get to 5, again, we multiply this by the 0.91, exactly as we've done before. 5 hours, we get 156 left. Still not there. Go again. Sometimes this could take a few steps to do, which is why in later videos we'll look at how we can do this quicker and easier. After 6 hours, 141. Again, still not quite there. 7 hours, again we times by 0.91. We get 129, so we're nearly there, but remember we want less than half, so less than 125. So logic dictates after this hour we'd be done. We still need to just double check and make sure, multiply by 0.91, and we get 117 couples left. So therefore, after 8 hours. After 8 hours we get less than half the couples left. That's a heck of a stint line dancing. But there you go. That's how we work it. It's just the same steps over and over. That's the joy of a recurrence relation like this. It's fairly repetitive. We don't have to do much beyond finding how much does it increase or decrease by every hour, and how do we calculate that quickly and efficiently.